Okay, so the last example we talked about a problem where we had a multiplication problem, and we discovered that we definitely needed to actually do the multiplication. In our next example here, we're going to be looking at a division problem where, once again, derivatives will not just simply distribute across the division because it won't do it for multiplication. So it also won't do it for division. So we're going to need to look at this process here now with derivatives with division. So consider the problem here, x cubed plus 12x plus 20. All this divided by x squared. Now again, I can tell you one of the more common mistakes people make is trying to distribute derivatives across the division problem, but that's actually going to give you a wrong answer. We will later on see how to handle this as a division problem, but even then you may want to just go with what we're going to be doing here, which is, hey, we're dividing by a single thing here. So let's just take each thing and divide each term by x squared. So we divide everything by x squared, and we go through and we simplify. X cubed over x squared would just be x to the first. Here we have 12x over x squared. We can cancel one of the things from the bottom with one of the things from the top, but we're still left with 1 in the bottom. And then 20 over x squared. Okay. And then for us to be able to do the derivative, though, these two second pieces here do need to be written as powers. So we can write this as x plus 12x to the minus 1 plus 20x to the minus second. All right, now it's written as powers. So we've done the algebra we needed to beforehand to get it into the right format. Now we take the derivative. Derivative of x will be 1. 12x to the minus 1, we multiply by the exponent. So we'd have 12 times the minus 1 would be a minus 12. And then drop the exponent by 1, become x to the negative second. And then we continue. 20 times minus 2 will be minus 40. Drop it by 1, the x to the negative third. And then we just clean up those answers. 1 minus 12 over x squared minus 40 over x cubed. So now we have our answer here, written out in the right format as well. Okay. Okay. So those examples there were both written with, excuse me, as a function and then finding the derivative. We can also see problems sometimes with derivatives written this way. And it means the same thing as the FF prime stuff. So here I have 2u to the 0.4 minus 7u to the 3.6. And so this just means take the derivative of all that stuff. So all of our derivative rules distributing across sums, our power rules, all those things apply here. Same idea as if I wrote f equals this stuff, find f prime. It means exactly the same. Except here, instead of dealing with whole numbers or fractions as our exponents, we're dealing with decimals. But the idea doesn't change. We're going to multiply by that exponent with our power rule, and then decrease it by 1. 0.4 minus 1 would be a negative 0.6. Okay, we continue distributing. Minus 7. Bring the exponent down. Drop it by 1. And then we're just continuing to simplify here. 2 times 0.4 would be 0.8. And then u to the negative 0.6, we move to the bottom. That would just be over u to the 0.6. And then here we just multiply out 7 and 3.6. Might actually be 25.2. And then u to the 2.6. And so there's our answer. Not the prettiest answer in the world, but sometimes we have some that look can look pretty bad sometimes. So that kind of stuff happens.